Thank you everyone for joining. Good morning to those of you in North America and those abroad over in Europe and other countries. Good afternoon, and hope this doesn't take too much of your afternoon away before you get to enjoy the weekend. What we'd like to do is just go over a few things about error handling. So talk about a little bit about transactions, how that works within the Mendix runtime. Go over some of the error handling techniques that you can utilize within your microflows, how you can handle various error situations within your microflows, what works when you have nested microflows, and most importantly too, error logging. So understanding when errors occur, what happened, how we get the most kind of out of the box features when it comes to these various topics. So to start, why do we have transactions? So a lot of people are familiar, I'm sure, with database transactions and how that is used to manipulate your data, persist your data to databases. For Mendix, we have transactions that encompass basically an entire microflow or series of microflows. All of our transactions follow a very simple methodology called ACID. Each of these letters represent a different piece of the transaction. So each transaction is going to be atomic, to where we either say all changes or no changes are applied. They're consistent, so we know that the state of the object is always consistent from the beginning and the end of a transaction. These transactions are isolated, so that means if I'm running a transaction against a certain object in memory or on the database, it's isolated from what other people may be doing in the applications as well. And lastly, they're durable. So after the process is finished, the data is permanently available within the database and still usable in the user session in the cache. Some facts about these transactions is every microflow is a transaction. So regardless of big, small, multiple nested microflows, at the end of the day, you should really have one big transaction that's processing all of the data manipulation and CRUD operations against your database. By default, every action in a transaction will be when an exception occurs. So if you're ever processing information, you're going deep into subflows and such, if you hit an exception and it's not being handled, everything from start to finish will be rolled back and you'll be back at the beginning state of your objects. Every changed object will be locked to prevent dirty reads. So what this means is that if I'm queuing up database transactions within my microflow to commit objects or insert objects, either those objects are invisible to outside people, or if I'm in the process of committing, those objects are not readable to other users in the system. So it's actually going to lock those rows so you don't get dirty reads. Someone's not pulling the last iteration of the data. It's going to wait for that process to finish and then send the users the newly committed object upon a retrieval. Like I said, whenever that transaction is running against the database, no other user will be able to use those locked records. So there are functions built in, and there's queuing set up in the runtime to prevent things like deadlocks and the ability to have competing threads trying to update the exact same data or pull data while it's being updated. That's all being queued and processed appropriately. Once the transaction is closed, and that means kind of the whole transaction of a microflow in whole, once that microflow finishes cleanly, all locks are released and everything goes back to that consistent state that I mentioned about those ACID transactions. So it starts in one state, it finishes in the same state. And if we don't specify any error handling within our microflows, everything is set to rollback. So as I mentioned before, if I run into an issue, if I hit an error when I'm 10 microflows deep, it's going to roll back everything start to finish because I haven't set any specific error handling. So how we do this is we do a little bit of configuration within our microflows. We have several ways to do this and several different actions or error handling techniques that we can use within our microflows. The first one is custom without rollback, which means if I hit an exception on that microflow or that process, I'm not going to roll back my changes in that microflow. However, I'm going to do some kind of custom workflow or flow outside of that activity that I can then follow up with a new transaction. If I run error handling custom with rollback, it's going to roll back everything within that microflow. However, it's still going to give me that error handling output to where I can do further manipulation or further logging that's going to be required once I run into an exception. You have the ability to continue, which, of course, we do not truly recommend that you use. It's basically, for you software engineers out there, it's when you have a try-catch, continue is the catch. So if you're anticipating errors or exceptions, you should really kind of work around that and try not to use continue unless you really have a situation that calls for it. By standard, we have just end events for every microflow. So every possible logical endpoint has to have an end event. But when you're working with error handlers, you have the ability to have an error end event, which, if that's within a nested microflow, it's going to rethrow the error at the very top level. And we're going to get into that as we go through the webinar, and I show you a couple of examples. So to start this off, if we look at this microflow, this is just looking at various attributes and doing some exclusive splits on it, and then showing validation messages. So the question is, does this microflow start a transaction? Well, the answer is yes. It does start a transaction, but only a Mendix transaction. So what that means is the Mendix transaction that encompasses the whole microflow takes place. However, there is no corresponding database transaction that opens the connection to the database because we have no actions or activities that explicitly ask us to do that. For the purpose of the webinar and kind of how we go forward, I'm going to use transactions synonymously to encompass the full Mendix transaction. So regardless if it has a database component or not, a transaction is a transaction is a transaction. So we're going to keep that very consistent so there's no complications on that piece. Subsequently, if we have a microflow that does interact with the database, it does start a transaction, but the database portion of the transaction is only going to be instantiated once I actually do the commit. So in this microflow, you'll see I change the customer status and I commit it. At that point, it's going to start the database transaction, and everything else that happens before that is only in the Mendix transaction. So for the purposes of going through some of our examples, we're going to look at a very simple workflow to where, as a customer, I'm committing an order to my database, and once I commit my order, it's then going to subsequently update my status as a customer. And so everything that goes on in this sequence is really one transaction. So the microflow that we have and the subflow are truly going to render as one transaction with multiple parts to it because we don't have any error handling specified. So in the event that we have an exception, it's very important that we understand the flow of what's actually taking place here. So in this sequence diagram, which we will use for the remainder of some of these examples, is you'll see that we have a user that then presses a button to submit the order. When the user submits the order, it calls a sub-microflow to update the customer status, and both of those microflows communicate with the database to have commits and then send data back. During this process, the shaded area is where the transaction takes place. So if you see on the submit order, we commit the order, we start the subflow, and the subflow successfully completes. Everything is good to go. So in this state, we have, as you can see, an order of ID 1234, a date of January 1st, 2014, and a customer of ID 1234 with an updated status of gold. Now, if say we were updating from silver to gold in our customer status, upon hitting an exception here, since we have no error handling specified, it's going to roll back the order and remove it from the database, and then it's going to actually set that customer status back to silver from gold because we hit an exception somewhere in the process. So since everything is rolled back, both of those commits are reverted, and the objects go back to the initial state that they were in. Now, one way to approach this situation would be to set custom without rollback. So if I, on my customer or update customer status subflow, if I set a custom without rollback error handler, what I'm going to be able to do is allow the parent Microflow to still commit and work properly. However, my subflow is not going to roll anything back on the parent. So in this instance, what's going to happen is you'll see that we have a commit that takes place. With the subflow, having a custom without rollback is still going to create that kind of isolated transaction to roll that back in the subflow to update the status, but the order is still left untouched. So to show kind of what this is doing under the hood, this update customer status is going to retrieve some information, it's going to sum some information, persist the data to the database, but after it persists, we're going to do a calculation on this object, and that's what's actually going to throw our exception. So what's going to happen here is once we get into that subflow, it's going to execute those activities or actions in order, and then we're going to hit an exception at the very end. So beginning state, we have no order, and then we have a customer that's in silver status. Once we commit the order, we have an order persisted to the database and a customer status updated from silver to gold. However, we then hit that exception at the end of our subflow, and since we have custom without rollback set up, we're going to still have that order persisted. It's going to exist in the database. However, if you see, the customer state is back to silver. So with that nested transaction, it's saying everything that happens in that lower level, roll it back because we hit an error, but don't roll back anything else because we're customly handling it. So to show this process with our sequence diagram, what's going to happen is we're going to start that transaction to commit the order. Then we run the sub-microflow that is going to have an exception, as you can see depicted by the X. That then is going to roll back our status update and then still allow us to persist that order. So everything in the orange here is a clean transaction going to the database. The dark shaded area is what's going to be rolled back. So on the flip side of that, you can say, I want to do custom with rollback. So keep in mind, though, the fact that we're doing custom still means that we have an outbound sequence that's going to happen. So once we hit that exception, we still have the ability to do stuff to the objects in memory or log items or do various things, and we'll get to that shortly. But if we were to do this same situation with rollback, what's going to happen is we have, to start with, no order in the database, and we have a customer with a status of silver. Once we commit the order, we have an ID of 1234. It's in the database. We have a customer status updated to gold. However, since our sub-microflow tells us to roll everything back, it's going to supersede and treat everything like a normal rollback. So it's basically the same as having no error handling installed, except that you have a custom flow that you can then work with once the error happens. The key thing to keep in mind here is that when you have with rollback, it's going to supersede that parent microflow and roll back the order as well and remove it from the database because it treats it as a full exception. However, what also happens in that instance is if you see that blue section below, when we do custom with or without rollback, it starts a subsequent transaction once it rolls everything back. What that allows us to do is to then say, okay, everything just got rolled back. We lost all of everything. However, since we still need to do something such as logging or reporting or alerting people that an error has taken place, a new transaction spins off just to handle the error output. And I'll show you what that means now that we look at a few practical use examples. Say, for instance, I want to, in my application, send a welcome email whenever I create a new user. So I've created my new user, everything is good, right? But if the email fails to send, we want to still commit our user to the database or our customer to the database, but we don't care that an exception occurred on the email so much that it's going to roll back the commit to the database. So what I would do in that instance, you can see that I have a microflow here that's going to commit the account, and then it's going to send an email task. So you see here we commit the account, and then we're going to send the email task. So in our example, we wanted to say, if the email fails, still commit the account, but let us know that the email failed. So what we're going to want to do is we're going to set our error handling to be custom without rollback, because we don't want to roll back our changes, but we still want to know that an exception occurred, and we want to do something about it. So what I'm going to do here is, first and foremost, I always want to log a message. So anytime that I run into an exception, whether handled or unhandled, I want to make sure that I'm logging it. I'll set my log level to error, so I know it's going to come into my log as an error. My log node name has to be set, so I want to make sure that I set that to something specific, so when it shows up in the log, I know exactly where it took place. So I'll say error and send email task for a new user. So when I see this happen in the log, I know exactly where it took place. Here I will say error in email task, and I want to include the error. I will also want to include the stack trace just so I can debug this further upon actually running into an exception. So I'm going to grab the latest error from memory. I'm going to get the message, and then what I'm going to do is I'm going to grab that again and get the stack trace. So what this is going to do is, once it actually hits this sequence, when I set it as event handler, is going to create a new transaction for the log message. Even though this is a flat file, I can still spin off other more complex workflows at this position, and then I can have an end event that will capture this error. What this is inevitably going to do is it's going to run the send email task. If it fails, we tell it to not roll back my account, but log an error and make sure that that shows up in the log. The logging is one of the most critical things that you can do with the actual modeler itself, because understanding where log or errors take place and understanding the depth of them is really critical to how you handle them. So in this instance, we use the custom without rollback error handler to make sure that, one, the new user is still committed to the database, but two, we're not actually rolling that back whenever we hit an issue with the email. Another practical use of using these different error handlers is when the user submits their order, an exception could occur, right? So I'm a user, I'm in the system, I want to submit my order, and it bombs out on me for some reason or another. So say in this specific instance, the business has decided that they want the customer to be flagged as having failed orders or cannot send an order so that someone could follow up on it. What I'll want to do here is I want to use custom with rollback so I can capture the issue as it happens and then set my status to failed on the actual customer themselves. So in order to do that, what I'm going to want to do is, within my microflow, to submit the order, is I'm going to want to put some custom error handling on here to know that something has taken place, and I want to capture that error. So in this instance, if I go look at my update customer status, if something fails within here, or say I want to capture if an error happens while sending an email about changing the order, I can go in here and set my error handling to custom with rollback to change the customer status back and to roll back the order itself. What I'll do here is, of course, I'll add a log. I'm not going to fill it out because I just want to show this that we would always log it. However, when I set this as error handler, I get the red X telling me that it's going to roll everything back. And then what I'm going to do is actually change the customer status. So since I have my customer in the Microflow, I'm going to change my status to failed. So what this is going to allow me to do when I commit it is this is going to spin off a whole new transaction that's totally separate from the previous Microflow and the parent Microflow. So when I say log the message and change this customer status, it knows that I want to still change the customer status in a brand new transaction, but roll everything else back. And I can use my end-event error Microflow here to not only throw the error in this Microflow, but it will throw the error in the parent Microflow as well. So once that happens, I'll know, even if I am doing custom with or without rollback, I'll still be able to pull at the highest level what that error message was. Okay, so I know we have a couple of questions from the group, so I'm going to take a minute and address those. So the first one we have is the order actually stored in the database before the subflow is started? So what's going to happen whenever you have a Microflow with multiple transactions and multiple commits, it's just going to queue those up in order. So if I say commit in my parent Microflow and then I commit that same object in a subflow or a second subflow, it's going to queue them in order. So even though it fires 3 update statements or 3 transactions to update that record, it's going to go in order. And it's going to, like I said, just queue up those statements, not necessarily run one and then a little bit later run another and then run another. It's going to run it as one big transaction. So I hope that answers your question, Dirk, out there. Another one, we have, why can we not use custom error handling within a loop? That's a very good question. Reason being is when you're within an iterator, you want to be able to set the error handler at the parent level and encapsulate that within a subflow so it doesn't, or I should say, so you can allow, I guess, more concise error handling. There's been a lot of debate on whether you can or cannot, or should not do error handling within loops. What we found is that whenever you have something even like a continue or a continue without rollback on a loop, it works the same to have a parent Microflow call a subflow with a loop in it and have the continue with rollback in it. So it will still iterate, it will still get through whenever it hits an exception. However, you just have to set it at kind of a parent level instead of at the actual iterator level. Another question we have for right now is, how is the necessity for error handling defined? What is the best practice for defining the amount and nature of tasks that require error handling? This is a really good question too, and this, I think, speaks to some of the things that I'm going to also touch on throughout the rest of the webinar. But this is something that my approach to it is you want to not overdo it, but you want to be smart about it to where Anytime you run into things like integration points, emails, web services, anything that's going to either communicate externally with other systems or communicate with very long-running processes, that's where I'm going to want to put in a lot of error, or not a lot of error handling, but I'm going to want to put in the places where I think there may actually be an error. On the same token, I don't want to anticipate errors. So if I think, for instance, that what I'm doing or my microflow has a high risk of throwing an exception or having a high risk of erroring in any way, shape, or form, I'm going to want to put in the legwork to vet things out before I get to that point. So checking to make sure things aren't empty in my object or null. I want to make sure that certain statuses are set or certain other processes have completed before I actually run the microflows or the actions within those microflows. And what I mean by that is, if I think that there's an exception that's going to take place, I usually think that by tweaking either the model or the microflows themselves, we can eliminate a lot of the potential noise by prepping for it and anticipating it by handling ahead of time. But we know that's never a perfect situation. So I like to start the focus on mostly integration points and emails and then build it out to some of my more complex processes. So microflows here. So the ones that we're going to be working with as we kind of look more into the sequence diagrams and some other situations that we can run into is the set that we have been looking at, right? So at the base, we have our submit order that commits the order, updates the customer status. In the customer status update, we know that we're going to retrieve a few data elements. We're going to change the status. We're going to send an email, and then we're going to log our message, throw an error event to make sure that we know what's going on. As we've gone through those examples, we've looked at the custom with rollback, the custom without rollback. I like to reiterate what's a good situation to use continue. Really, we don't want to use continue if we don't have to. Like I said, it's like a big try-catch, and you're putting more into the catch than you really should be. So try to be creative with looking for data integrity, looking for the population of your objects, look for the validity of certain things before you process them. But sometimes if there's very, very complex situations or very deep logic that you just don't know what's going on, you can, that's sometimes when I'd use a continue, but I try not to ever because I want to know what's happening and I want to be able to trace it, not sweep it under the rug. So with our sequence diagram, there's several different ways we can configure this with several different layers of error handling and different points within our subflows. In this situation, if I set rollback at my very top level, what's going to happen is with my first subflow, if I say I'm putting continue with rollback, as I go through this process, the second that I hit an exception, I'm going to roll back all changes because my highest level dictates it. My highest level says we're going to roll back whenever we hit an exception, so no matter what happens, we're going to roll that back. So as we've looked at before, everything that goes on within this, this transaction itself will be rolled back, but that blue area down at the bottom is going to show that we have a new transaction that will be spawned. That transaction will then allow us to do those custom pieces such as, update the customer status to failed or the order status to failed, log messages, or even send an email or an internal message to the system to say, hey, we've run into this issue and this is what's going on. So in this situation, to reiterate kind of what we're doing in the consistent theme, we have an order and we have a customer with a status. We have an order that gets persisted to the database based on the microflow logic, updates the status to gold. However, we hit an exception, the order is rolled back from the database, and the customer is sent back to silver status because we don't have, or we do have the rollback set at the highest level. Subsequently, what happens if we decide that we're going to continue without rollback at the highest level, but we do have rollback specified in the next level down? What's going to happen here is we're going to go through the same steps. We're going to commit the order, start the subflow, retrieve, commit. Now, during our email task, we hit an exception. That exception says we're going to roll back at that level, and then we have it rethrow the error. What this is going to do is it's going to say, for this transaction, we're going to commit the order. Everything that happens after that, once we get into the next level down of error handling that says, hey, we're going to roll back at the next level down, it is going to roll back the lower level, but the top level is still going to commit to the database because we've specified at the highest level continue without rolling back. So what this is going to do to our object state is that you're going to see we have no order in the database, a customer status silver. We now have an order being persisted to the database. The customer status is updated to gold. But once the exception occurs, since the parent level is set to continue, we're still going to persist that order to the database, but the customer status, you can see, is rolled back from gold to silver. The other thing to keep in mind here is that since we're using that error end event, what it's going to allow us to do is capture the error at the top level just for whatever usage you might want of it. It's not going to stop transaction. It's not going to halt that top level, but it will allow you to read that error out if there is a lower level error that's thrown, because it rethrows the error in an informational way since it's set to without rollback at the very top level. In this instance, we have the same setup, but we're using custom without rollback at all levels. What this is going to do is it's going to run the transaction. We're going to start our sub-microflow. Then we're going to run into an exception when we're sending that email. But we've said that we're going to continue without rolling back even at the finest level whenever we hit that transaction. So we start, no order, customer silver. Second step, orders committed to the database. We update the customer to gold. However, since both are set to custom without rollback and the email is the section that fails, we're going to still have the order persisted to the database. We're still going to have the customer status updated to gold. However, we're using the error end event, which is going to allow us at the highest level to understand what error actually took place. So that rethrowing of the error allows us to manage that, but all the data is still going to be persisted. So we can keep getting into more of these types of situations. So if our parent says rollback, but the child says continue without rolling back, when we get through this process, what's going to happen is the entire transaction from the very parent all the way down to the child is going to be rolled back. The reason that happens is because it's at the very top level. If I specify there's going to be rollback when any exception is hit, it's going to roll everything back. So when I rethrow that error, it's going to know that we hit an exception. The top level says, hey, we're going to roll everything back just because that's what we decided at the top level, and that supersedes everything down at the lower level. So the fact that we're rethrowing it, we have it specified at the highest level, it's going to roll everything back, and as we go through our status, you'll see the order is not in the database and the customer status is still silver because that top level is really going to run the show when it comes to what happens in subsequent microflows. So I know that's a lot of information. I know it's a lot of it's an easy situation or example, but the situations get complex very, very quickly. So some best practices to keep in mind whenever you're doing this. First of all, avoid using the continue error handler. Like I said before, it's kind of like sweeping things under the rug. If you've ever been a developer like myself in the day when you really just wanted to get stuff done and didn't have enough time to do enough testing and your catch block had a little bit too much in it, that's the same as having the continue event error handler. Try to avoid it. Try not to use it. It really just causes confusion and the inability to debug issues whenever you're in a production environment. Always, always, always use a log activity to print your error messages and include the stack trace. Whether you're working with just microflows in the modeler, if they're calling Java actions, if you're running web services, REST services, whatever you have going on, the ability to print that message in the stack trace is going to make debugging so much easier. So always, always, always log what's going on. It may even be helpful to log the user that triggered the error so you can know exactly what that user was doing at what point in time, get a little more information. Always add custom error handling on integration and email activities. I can't stress it enough. Anytime you're communicating outside of your runtime, always have something, whether it's flat files, mail, web services, REST services, always encapsulate those within some error handling and logging because it's very key to know what happens whenever issues do arise. And try not to anticipate exceptions. Like I mentioned before, if you are anticipating that exceptions are going to occur, maybe you should, take a second to step back, rethink the way your model's built, rethink the way your microflows are aggregating or manipulating data, and see if there's a better way of doing it to try to mitigate the chance of exception. We know it's never perfect, but don't bank on the idea that, oh, I'm anticipating errors are going to happen, because you'll want to be sparingly, because you don't want to overdo it, right? You don't want to have error handling in so many different levels, in so many different places, that it actually becomes a deterrent to debugging. So it's to one of the individual's questions earlier, you want to be smart about it. You want to think about where you can truly have something out of the blue that you don't really know how to handle, so you can capture that information. Or if you have something that you just really always want to capture information on, always put in your logging, always put in the error handling. But be smart about it, and be sure to ask questions. Look at the forum. Ask questions on the forum about, hey, I have this certain situation, this scenario. It's great to get that expert feedback and have someone do a little bit of a review too, to say, hey, is this error handling make sense? Does it not? We're always happy to give our feedback, especially on the forum, and assess some of those situations. So one of the things I'd love to do now is just turn it over to some question and answer from you guys. I know we have about 10, 15 minutes left, so definitely ask questions, and would love to hear from you guys. All right, so in a published web service, if exceptions occurs and we have custom with rollback enabled, but how can we change the response message and send them the detailed response to the exception message on what caused the web service to fail? That's actually a really, really great question. If you have custom with rollback enabled, you'll want to put the error handling on the web service call itself. So one of the things that I would do there, and what I'll do is I'll show you my modeler. So I'll want to set something up like this. So if I'm calling a web service, I can set my error handling on that. It doesn't have to be specifically a microflow that I'm setting it on. What this allows me to do whenever I call a web service, I can still log my message in a very verbose way. I can also throw an error message to the UI to tell people what happened. And in here, if I want to be explicit, I can still put in my parameters and give them the exact message to the UI. So that's one way that I can bubble that exception up. But if I also am several layers deep and I'm nested down in microflows, I can change my error end event, or my end event to be an error one, so then it's going to rethrow the error at the very top level. So even if I'm handling that exception, what I want to do is rethrow the error so then I can process it at the highest level and understand it. And hopefully that answers your questions. If there's any follow-up to these, feel free to let us know after the webinar, because we definitely want to get you all the answers we can. All right, so we got another one. We have a formal Oracle SQL Server programmer. So a commit is not a commit because it can be rolled back. This is a very, very good question. I myself have a very lengthy background in database management, transaction management, so I think I can speak to this pretty well. So what happens, whenever you commit, it's going to queue that up as part of the transaction. So if I'm committing 10 objects, really what the modeler is doing is it's queuing up 10 either insert or update statements that are going to run in sequence. So if I'm inserting one object and then I'm updating it 3 times, which I should never do in one microflow, I should only really commit it once, but it's going to queue those up and process one at a time. So once we queue that up, if we hit any exception within that transaction, whether it be on the Mendix side or the database side, it's going to roll everything back. The runtime knows how to encapsulate all of the processes going on or all the actions going on from the Mendix side and the database side into one massive transaction, and it's built to design to roll back on an exception on either the Mendix side or the database side. All right, good question we have coming in about locks on the transaction. So yes, I mentioned that while someone is updating information in a transaction, what it does is it actually puts the requesting user on hold so that we can finish the process, and then that person would get a clean read once the object is made available. So you shouldn't run into deadlocks. So if you do, let us know so we can help you investigate what's going on. But really, the runtime should be handling deadlocks to where if you're waiting on data, we're waiting until the commit to take place. Once the commit takes place, that data is readily available for the next users. Next question. When there is a commit in an activity, no subsequent rollback can undo that commit. If the commit takes place within one transaction and we have an exception later down the road, it depends on how your error handling is set up. So if you commit in one microflow and then you trigger a separate microflow, not a nested one, it will not roll that back. But if you have an exception, any point within the same microflow as the commit or in a nested microflow with the commit, if anything is set to roll back, it's going to roll back the entire commit activity and you're going to be back at square one. So within a lengthy microflow, is it possible to batch updates into multiple transactions? Good question. It's actually going to process everything as one transaction. So you can't batch it, so to say, in multiple ones. You can batch the way that the memory is handled within the microflows. However, what it's going to do is it's going to queue up all of those database transactions and run them at once. Reason being is that depending on how my error handling is set up, I'm either going to only roll back a little bit of that or I'm going to roll back all of it. And the runtime's going to know how to handle each of those transactions or each of the pieces of the transaction to know which to still commit and which to not include in the ending SQL statement that's posted to the database. Are locks record of table locks? Yes, so the locks that I'm talking about are at the table level and at the row level within those tables. So it's going to lock the row on the table, so anyone who reads that table is not able to read the data until that lock is released. As shown currently, the submit order is rethrowing an exception. How do you catch it in a higher microflow? That's a good question. So what I would do there is I would actually, in my parent microflow, so say if I was having an end error event in my end customer status, I would set my error handling to custom without rollback, so then I can still capture the activity. When I log this message and set my error handler, I'm going to know that when this subflow rethrows the error, it's going to tell me that here, and I can process it here in my log message, because it's going to tell me that I did rethrow the error. And I don't even have to end here. I could even have this merge back in and say, if something happens here, it's going to rethrow, but I'm going to continue and I'm going to still go along my microflow as intended.
All right, thank you everyone. Those were some great questions, and thank you, Marshall, for talking us through them. And thanks again, everyone, for joining us, and enjoy the rest of your day.
Thank you, everyone. I appreciate it.